contrary to the fact that it's at a COVESA event, it is not about COVESA. It's about a bigger challenge that we're calling software-defined vehicle, and it's about what does the industry need to do to attack this beast and to identify who should own what and who should do what, and how those owners of that technology should attack those things in such a way that the industry benefits the best in the end and doesn't spend too much time gluing and integrating and doing special things with the deliverables of these respective organizations. So this is the only slide, and at this point I'd like to just suggest that we do a quick round of, since we're small, let's do a quick round who's here, and then we begin to answer the question, what organizations do we know are doing things in this space, what are they doing, and how should we begin to map those to some sort of a strategy or a continuation of this discussion in other contexts. Yeah. So why don't you start, and then we'll go around that way.
Okay. So my name is Jean-Louis. I work for NXP, Silicon Vendor. So far away from the software-defined vehicle, for sure. But really, the more we do, the more we go, the more we see the involvement of software within the powerful IC we need to define and to design for you. Okay, so I want to get initial information from you guys to make sure that we can have a better IC for you in the future.
Okay. Hi, I'm Sebastian Seiler, part of Mercedes-Benz Vans, and I'm in the team that develops an ECU that is similar to a Raspberry Pi, but automotive grade, and we want to connect external hardware to our vehicles and also external backends, and I'm working as a software developer and software architect.
Hello, Martin Pfeiffer, CTO of NXP. We are a navigation company, formerly working for EA Technologies for 10 years and for Visteon in the area of self-driving cars. I'm accidentally here, I wasn't even so, but I mean, yeah, I think for me this software-defined car idea is term all over the places, and we were at AEK last year, it was always hot, right? So what is software-defined? I think for me, the middleware is important, but probably it's also related to how these OSS signals are covered or collected and then, provided by the sensors and stuff like this.
Michael Niklas, I have two hats in this discussion session. The hat you already aware about is Deputy Chairperson of AUTOSA. The other hat I'm wearing is in the software strategy department of Continental as a Tier 1 supplier. We are very much looking into software-defined vehicle and which organizations can play which role. So it's not an accident that I'm Deputy Chairperson this year in AUTOSA, also participating in such meetings because I would like exactly how you stated here, understand how can we as an industry team up and split the work. Because at the end of the day, we don't have enough engineers in the market that each OEM does an own automotive OS, and we have a lot of non-differentiating aspects, so it's also not worth that each organization does the same parts of the non-differentiating aspects, but we should split the work between the organizations. So I'm really looking forward to discuss with you. Thank you.
Totally Christian Kastan, I'm with BoF since over 15 years now, and I'm very much into the common vehicle interface initiative since 7 years now. We're discussing centralized architecture, service-oriented EE architectures, and everything is heading towards bringing all the software together, but still we are discussing the second bit from the left. This discussions, and this will not help. So again, don't reinvent all the time the wheels. We have so much work before us. Let's do the ugly stuff together and then differentiate where that's possible.
All right. My name is Christos Papadopoulos. I'm from the University of Memphis. I'm a professor there, and I'm here because I'm interested to learn about what a software-defined vehicle is. My background is networking, especially network security, and I understand what a software-defined network is. So I'm really curious to see what a software-defined car is going to be. So I'm here because I want to get ideas for research for our students, and also ideas on how to educate, how to build courseware, how to build education material that would help our students find jobs with you guys.
Okay, so I'm a master's student. My name is Mateus. I'm working at Bosch, and I'm here mostly to take a break from research papers. I think you're going to try to get the sense of the business view or the scope that my research is in. So, because I'm sure it extends far beyond what we see in articles and peer review papers and stuff. So that's the image.
I'm Katja Mattes. I'm with Renault Group. I'm the CTO of the Renault Software Factory. And among the technologies I take care of, most of my time I spend on software-defined vehicle as a whole. And from where we come from, current architectures, to go to software-defined, service-oriented architecture is quite a disruption. And it's also an opportunity to restart in a better way, including working model, doing much less customization. And one of the things we really believe in the software organization is to start and contribute to open source projects. And the other dimension that's also very important in software-defined vehicle is cybersecurity. Because of IP and Ethernet based backbone, mainly used with software-defined vehicle, the attack surface is much bigger in software-defined vehicle compared to original traditional EE architectures that are more CAN-based.
Hi, this is Jota. I came from Hyundai Mobis, Tier 1 supplier. So my basic understanding about the software-defined vehicle is integration of the vehicle controllers. So even Mobis also currently we are in a stage of moving forward to from distribution computer to domain computer and the general computing perspective. So that we are aiming to make the more development effectiveness or cost-wise effectiveness as well. So a lot of the discussion is happening inside of the company, and also we have some other viewpoint regarding the so integration of the vehicle controllers. So last 2 years we have suffered from not only from pandemic but also shortage of the semiconductors. So so from our observation, most of the shortage of the semiconductors came from 8-inch wafer. So legacy type of semiconductor was most of the vehicle microcontroller was produced through that procedure. So that's why we want to move forward to the 12 inches, more high-end chipset we want to utilize. So we believe that if we will move to the integration system and the high computing system, then we will solve that shortage, the semiconductor shortage problem.
Hello, Richard Sardi. I'm Ricardo, so like an engineering service provider. So for the day job, I'm working on connected and automated vehicle applications, so mainly on the software side. Within Ricardo, we work with lots of OEMs, so not just passenger car OEMs, but like off-highway and various types of companies. And there are many discussions about software-defined vehicle and how can I get my architecture from here to there. So we get involved in those discussions. So I'm here. I need to listen, but hoping to contribute if I can.
Steve Crumb, Executive Director of COVESA. It's easy. And self-subscribed secretary and of this particular session. So I'm going to try to record the main thoughts and get the notes out to everybody here. So,
Thank you.
so I suggest that there's an easy question and then a harder question that we can start with. Okay, the easy question is the organizations that are listed here are the ones that have been talking about SDV for some period of time and either have an active SDV activity or want to start one. So the first easy question, I think, is are there any organizations obviously missing that should be on this list and should be thought about when we're, and I don't want to create a comprehensive list, but are there any other organizations that any of you are aware of that should be on this list for consideration?
Maybe not holistically, but we did a study and there are also certain organizations which have a certain domain knowledge which might play an important role in the SDV landscape. At least we have investigated that. So for example, we talk about hardware acceleration in a vehicle. Kronos would be interesting to talk about. They're doing OpenCL, SYCL and all of the acceleration parts. But of course, it's not 100% SDV. It's part of the SDV ecosystem that might come into my mind. We have also all of the cloud-related initiatives in Europe. At least there's this Gaia X, which is quite important, I would say, from getting independent, which also is important when you talk about software-defined vehicle. And that's it for the moment I can think about on top of my head. Latina X, yeah, also. Yeah.
We also have Monet in Japan. And talking about such a thing as SDV.
What was that again, Mo?
Monet as a artist, painter, whatever. Cool guy.
Yeah.
And there's the SDV activity in the CAAM, China's Association for Automotive Manufacturers, that recently released the second version of their API specifications, which are going in the SDV direction worldwide, I would say. It's already local activities.
They have, I don't know how the activity is called. I have the feeling it's driven by Huawei in China. They also driving a kind of vehicle API and trying to...
This is the C.
Okay,
yeah.
perfect. Then, okay, thanks.
Yeah, they're doing this in the CAM umbrella.
Okay. Okay. Anybody else?
Our hyperscalers, like Google and Amazon.
And there is this, I recall where Kubernetes and all the other things are developed, a cloud consortium, I don't know exactly for
Cloud native?
Cloud native, thank you. The Cloud native initiative. So you have all of the Kubernetes and other deployment agnostic stuff where you can then move software from A to B. Might be also relevant for the SDV.
Okay. I think that's a good list. We didn't put Tesla on the list. Was there a reason for that?
They don't want to play cooperatively.
Have we asked?
Yes.
Okay.
Some years ago.
Me not, but
Okay.
Things might have changed in the meantime.
Twitter is called perhaps.
Yeah.
So the second question I would pose, and if anybody has a better one, please take the lead here. But the second question was, what do we know that some of these organizations are already doing? If somebody can describe briefly, if there is a known charter or a known work group that's already, or a project launched in any of these organizations, what does that look like, and how do those organizations reference that? So I know Eclipse has started a SDV group,
Yeah.
and I think it has a charter, right?
Yes. I mean, we've been in the founding members.
Right.
And I've also organized membership. So, I mean, Eclipse Foundation is more looking in a big, great scope. So what's to integrate, which pieces of open source software, which pieces of standards to integrate in the big box. So its charter is very broad, I would say, yeah? But it's less a charter of doing one single thing, as I've understood it, but more or less making a lot of other things compatible with each other, bringing those together in an open source kind of way. Yeah.
So more of an integration and alignment activity.
I would not slowly to that, so also complete project proposals and so on.
Yeah.
So which open source project to consider. I mean, this definitely, but in principle more the framework, the overall thing. Yeah.
Can anybody represent Sophie?
So Sophie, that has been, let's say, put in place by ARM. And the purpose is to have a reference architecture for what they call it's service-oriented architecture for embedded edge, something like that. And so it's looking at the different layers and the ingredients to say, okay, we need a hypervisor. Then obviously you have virtual machines, but also in the evolution, containers, orchestrators, and having a roadmap to include the safety aspect, meaning mixed criticality in orchestrators and VMs. And obviously the hypervisor needs also to be based on that.
From my point of view, they trying to, you said it with the Raspberry, automotive Raspberry Pi thing, so that would be my expectation what's coming out of Sophie. We have hardware and it just works, and don't be a pain in the ass with the software and bootloader and everything. And then we can do all our cool stuff on the top.
But they're very much focusing on the edge part, right? So the connection to the cloud, as far as I understood. And the mixed criticality orchestration is also something I've heard from our internal Sophie colleagues. That this is relevant, yeah.
I would have a question.
Yes.
I'm really looking since 3 years or 4 years for a killer use case for all this service advanced thing. And yesterday we had an independent discussion. We will never sell more cars because we have it, but we might sell less when we don't have it. And the question is this just me missing this killer use case, or since all the time the hire managers ask me, hey, okay, show me how you get, or what's your use case to get the next trillions of dollars and whatever, and I'm always, there is no, so perhaps if you have one, then we can put this into COVESA, and at least we have one that works. If you have one and want to keep it for yourself, then please say you have one, that's fine.
Killer use case for what specifically?
For this, why should our BMW colleague draw this street line? They said on the left side we have heritage, we have some things already set. And nonetheless, this line was not, okay, this is a vehicle and then we draw the line, this is somehow in there. And so we have to talk to the people currently developing since 30 years in another way than service-oriented open source like the English. And they ask for these use cases. Yeah. And that's why I'm curious. If somebody found it, then I'm very happy for you. But please let me know, then I keep searching, otherwise.
Without disclosing too much, we have use cases that are not necessary, there's not necessarily one killer app. But what we observe is that to enrich the user experience, you need to get access to more data that's today buried sometimes in signals. And you need to be able to evolve the data you access to over time. And that's something we can't do with the current architectures because of safety. So we can't just add in the life cycle of a vehicle a CAN signal that hasn't been defined at production.
Yeah.
And actually it's not defined at production, it's defined years before production, because you freeze then, or at least at Renault we freeze the signal specification for inter-system.
Yeah.
And that's then how we test and we measure that the bandwidth on the CAN is always enough to get all signals across, and that they're all meeting safety requirements, because many of them are safety relevant. And that's today a fundamental limitation how you can build upgradable cars, even for applications we don't know of today. And all the cars we put on the streets right now, the only entity that is sufficiently upgradable is the infotainment unit and part of the IVC. And that's all. And that's not sufficient to improve user experience over time with additional information you want to pull from somewhere else.
But that would mean that you have, due to your physical layout of the car, the sensors and actuators, you can map this physical layout to a service layout, in the service domain, I would say, where you then access this parts of the signals as a read-only stuff for things like reading out via VSS, and things that you're setting, like actuator values, how much brake force you apply and whatsoever. Right? That's a prerequisite then, that you get this out of the CAN domain into a service-oriented Ethernet domain, where you have...
Yeah, that's I mean, the whole idea of, rather than having all these ECUs that at some point go to the gateway, and that many of them are connected to CAN network still, you have the zonal controllers, and these have are a bit like the hubs to have the sensors, the actuators, and the ECUs, and that themselves have access to most of the information, the signals, at least the relevant ones.
Yep.
And then you have the Ethernet backbone, and you bring from the zonal computers the information to the centralized computing entity.
That's what I was referring to. That,
yes.
So this would depict that in the service domain, I call it, when you have translated it from the signal to the service world, that you there can have a playground where you can also access this kind of data, which is in the time deterministic CAN domain very critical to alter and change.
But to extend that, in future, we have the street lines somewhere in the vehicle for the next, I don't know, 5 to perhaps less or more, I don't know. We have the stream line where we don't change the CAN and so on. Nonetheless, with just the information on the CAN, it is our understanding that this is sufficient and we will never touch it, or are we bringing in some placeholders, some dummy data or some dummy communication, whatever CAN IDs, to be able to extend in the future? So will we really not touch, never ever, this part on the left side of the stream line? Or is it just, okay, we can touch it, but only once a year, or...
Yeah, actually, I think when you build the image of the centralized architecture, the picture that Graham draw is a little bit changing, because you don't have that right, with maybe more top bottom.
Okay, yeah.
And then it depends how much bandwidth, how much free bandwidth you're willing to pay to make everything down to the CAN signals more upgradable. Because if you know that you have, by design, 70% of bandwidth free on each of the lines, then you're much more free to upgrade. If you don't pay that, you can tweak some flexible protocols so that you see I reserve like 10% of the bandwidth and I can play with the 10% with maybe some configurable signals that I know I don't have permanently on the CAN bus, but on request I know I can ask using diag protocol, whatever. I mean, diag protocol already, remote diag protocol already allows you to do so. So you can say, okay, I request on demand from even server side, you configure and then you put out the signals you want.
No, but this brings us to the point this perhaps Tesla and Elon has in the past. Currently we try to cost optimize our things. This would preserve us or hinder us a little bit to pay this extra heads for communication. And so when we want to do service-oriented software-driven vehicles, then we have to pay computation power, we have to pay bandwidth, and this not just goes into the vehicle computers, also in the EE line detection and everything.
Yeah, but the thing is, I think if there is an ECU, if you are able to represent the physics of an ECU, in the physics, I mean, there is an actuators, yeah? Towards the signals, it has to expose to the outside world. If this physics doesn't change, why would you add another signal? So I think it's a very rare thing that you would have. I don't know, just fueling a bit the discussion. So if the physics doesn't change, why would you need to change the signals at the end of the day? If you're doing a true decomposition of your system.
I can give you examples of the service area where, I mean, in the course of just discussion, whether it's with territories, you find that some of the signals that are not used for application inside the vehicles become at some point useful for doing services. And services are so vast areas that even signals you would never imagine you need, well, you can be useful for some services.
But then this is what I meant, you design your signals in such a way what the actuator sensor ECU maximum can offer or utilize.
But anyway, you can't get any signals out that are not produced.
Exactly, that's what I meant. So if you go the conservative, I produce and consume all of the signals I need, then why would you need to add something on top later on?
Because the system today is not designed to consume everything that is produced.
Yeah, that's true.
That would be too overkill.
Yeah.
So the fine balance is that you allocate some bandwidth to have extensions, but not to have a huge overcost of the system.
Yeah.
And the business balance about that is that the overcost you put in the car, which is already, at least in Window Group, a mindset change to what we do today.
Yeah.
There's where I've talked about cultural challenges we have, is that you largely compensate this overcost by the business revenue you can generate.
In the future.
Right.
Potential
And,
business.
and this potential business revenue, already the first word, potential,
Yeah.
is today a barrier to designing in oversizing the system.
Perhaps one additional thing might be also, when we talk about software-driven vehicle, are we talking about it's standardized in a way that it's, again, I have my feeling with this green line. So where do we put this very standardized thing? Where to put our applications which can run on a Mercedes, on a Renault, on a perhaps even on a Tesla some point in time to generate or give the third-party geniuses, startups, whatever, the chance to make some very cool use cases which enhance the user experience or driver experience. Because I have the feeling that we have to open a little bit, because we are not the smartest guys in the world. We are kind of cool, yeah. So otherwise we won't be here. But the real thing would happen when we open to the smart guys out there. And this does mean that we have to provide a scalable market. That's why I believe in this CBII thing. And because then we have to decide what are the services we can provide for a lot of cars, which are the services which can just run on El Renault, or which just are provided by sensors of Mercedes, or same for our IP vendors. How to deal with this and where to put all this. It's not about just semantics, it's also about syntax, about which containers we use, how to do this with homologation, and where do we discuss that kind of things. And are we willing to do, or do we need another 10 years to free ourselves because we have this tool?
Well, personally, I really would like within COVESA to define some of that stuff. Because you get some other enablers you need, like the hypervised infrastructure from some other programs, or even more Linux capability. Because if we want to build more open system, if we can build an open source components, that would be an advantage. And then the step is going towards standardizing the interfaces on which you build services. And the question is, can we do that together? Because up to now, if it's not a Google or an Apple defining APIs and providing SDK, there are, to me, few examples in the industry where this was successful out of an organization like COVESA. But this would, for me, be the ideal case that we manage to define up to that level.
It's the only way, I guess. Otherwise, Google will come in 2 years, or Android, Amazon, or who else? Hyperscalers. It's just a question of money.
If you're talking about interfaces could be on different levels. So it could be either on an interface like that we all agree. It's just like an example because I know it quite well. We all agree the velocity of the vehicle is some IP service with the name X. Well, the velocity of the vehicle is accessible via the C++ API and then the C++ API, or the velocity of the vehicle is accessible via the some IP service which is always the number 34. So these are all different kind of interfaces on which I could access and standardize. So what kind of interface level are you thinking about in this direction?
I'm thinking even a step further, which is putting together normalized speed information with maybe
Then we should
kilometer information, with fuel level information, and have basic function APIs, like it's the case in Android, for example, on which you can build an SDK. And then you have an environment where you enable third parties from all over the world, like it's the case for the App Store and the Play Store, to build services and applications that are interoperable on different types of vehicles from different brands.
And those interfaces would be then in the service domain, or would it be in an instance like an SDK where you can have the custom built software running? Because I could also imagine just a visionary thing to say, okay, if I can standardize a certain set of parameters that are the same and non-differentiating between a lot of OEMs, like for example, to indicate the left, to indicate the right, or the velocity. If take this and have a common catalog of that for the in-vehicle communication, for the service domain. The differentiation is done in the brand. For example, if my logic says I have to turn left, it doesn't matter if I'm having the smallest Renault or the biggest Mercedes truck. Turning left means I have to put left indicator lamp. And how it's then elaborated in a design is different design of the vehicle. So how does the vehicle look? Does it have a turn indicator in the mirror? Does it have 3 or 4 lamps, 5 positions, 6? I don't really care really. If the logic says turn left, right? Because the differentiating aspect is not that my car is blinking because it's normatively relevant, but the differentiating aspect is how does it look like, right? So I have a fancy LED that is running through, or do I have 4 or 5 other points that are also indicating that? Yeah. So there's no value add for any OEM in such standard features that are regulatory necessary.
Yeah, I think that's why we have VSS. The question is VSS enough for doing the actions, or currently I have the feeling VSC needs more acceleration. So going for the services, going for the next steps, and how to do so, because VSC is much more complicated. We're talking about semantics, we're talking about parameters, about syntax, about whatever. And that will be a big challenge.
Yeah, so maybe to give some answer to that, I saw, I think it was an Accenture study, like there is a potential of 70% of the vehicle functions that include like basic functions you're pointing to, that could be common between OEMs and that are not today, and for which SDV could be an opportunity to build such common thing. But this is, again, a complete mindset change in the automotive market to collaborate together, say, yeah, this is commodity, and we can build this together, and then we differentiate on the application, on services, and even some proprietary APIs that we will expose. We would work on the basic ones.
Because I could imagine if we are pulling this off in the industry, that also some of our complexity problems are getting reduced when we have to integrate complex systems, and 70% of the functions are normed and normality and are used the same way. Then also the integration complexity for each OEM is decreasing.
For me, it's a huge cost optimization opportunity. Because if I'm looking at the specs that we provide today to tier ones, there is not invented here syndrome.
Yes.
All over the
Both
place.
sides,
Both sides.
And if you have, so the opportunity to have a common specification and common function that are implemented once, then obviously they are validated and tested once for a complete basis of vehicles. And that will make the thing, if it's, the cost is then shared, fairly. Sometimes we pay things again at what's on your end, you have already developed and we still pay it again. But okay, don't want to get into this discussion. But I think to get really everybody together on that is to have this cost opportunity in mind, to share it fairly, and then to leverage and build on that, because you have a complete robust basis that is shared between everybody, and it becomes a sort of off-the-shelf product that you, and on OEM side you would be able to much more concentrate on building the differentiated part rather than redeveloping commodity parts over and over again.
If we make an analogy,
a long time ago, okay, what you're describing now. And the point is, it has been a pain for many industrial segment guys to accept what you're describing now, okay, making sure that there is a clean API, clean drivers, everything has been reviewed, and it's my IP, so I don't want someone else to review it because it's my IP. At the end of the day, this is because it has been the way that everybody had the look on what everyone was doing. But the quality improves over time. You reduce the cost of development drastically because someone else has done it, and you can reuse it and improve it, and the guy who did that before you is very happy because you improve his work. Because those people who are participating to this kind of activities are more open-minded than the traditional way of working 20 years ago. It's just a mindset issue as well, and you reduce the cost and the time. So, given that now you have, clearly, the cellular world, the industry, the automotive environment, it's three different environments. We are catching together over time, making improvements. And clearly you can see that you need 2 or 3 years to make a phone, maybe more, from the IC's perspective to a phone. At the end of the day, your car will be the same. You need to reduce this time of development in the way that people are very eager to get the newest and very nice car. Okay, so there is, I think, an end user request and demand and pressure from the guy here driving his car to get a new one. And everything goes to that direction as well. So I think what you're describing to me is complete sense for the future to come. But you have everything clean. And then you can build up upon that. And the people who are deciding today, or who have been deciding for a long time ago, they don't think that you can build up. But they are still thinking at low level, at higher level, but not very high. They don't come from the top, they come from the bottom. And then it's much difficult for them to change their mindset.
Perhaps we should invite the guys who already did this from other industries. Since this is in the road since 30 years now, we are just late. And perhaps we can learn. It's not all the same, otherwise we would have it already. Yeah? I'm pretty sure. Let's learn from the drawbacks, from what happened out there, instead of just doing more.
And another point which is important maybe is another way of taking quality enhancements is when it's not because it's a closed environment, but it's a better environment, but it's a more secure environment. Not at all. People have been thinking like this for a long time, and the more you open, the more people are reviewing this and improve this. And even if you talk about cybersecurity, it's a matter of improving the cybersecurity. It's like you're getting access to the, you can, like in the bank, if it's an analogy here, you can go to the, you can tell to the thief to go to the safe, no problem with that, as long as the Zeta has a key, and you cannot open it, you are safe. So it's a complete analogy here, I think. So even cybersecurity might be very open source, as long as the keys you protect are very well secured, for instance. It's another way of thinking.
So we are actually at the end of our time, and I know some people have to catch trains and others have to go to the reception and showcase. But what do we think is the next step? Do we think more discussion like this to get a perspective, bringing in other individuals representative of some of these other organizations? Should we talk more as COVESA first and sort of figure out what do we own and how can we begin to own it, or what are your thoughts?
From my understanding, we have COVESA is in a place where we might be able to bring a lot of these activities together. And COVESA will not be the place for me where everything is done and somehow come to Gunnar had this tech stack or a use case where we can do it together, or can we find a thing where we really can try to put the things and the thoughts together to get common understanding, to convince, and this is also the case, I guess, we all have to convince our colleagues and the old culture and so on, so we all face similar things, and there we have to come together. And the best thing I've learned from open source is not more beautiful PowerPoint, but just do and show that it works. And I think there are some opportunities to do so. We have these Eclipse and so on. We have a commitment of a lot of things, and perhaps we, as COVESA, might be able to bring in the fruitful ideas to how to show off and to convince them.
Yeah, I agree. So if you could set up maybe a work group in which we need different representatives, I think we need more OEM, Tier 1, Tier 2 service providers, and where we, I think first step would be to agree on the scope, where we are all willing to collaborate, and then maybe we can leverage some of the open source projects that deliver the foundation of the ingredients where we could build upon, and then bring some reference implementation that showcases where we want to go.
I mean, I could even think in the second half of the year, once each organization has made up its mind, to call for a summit of the biggest organizations. I personally would be interested in seeing representatives from Eclipse, STV, from Selfie, from COVESA, from Autosar in the same room, talking about that, thinking about where do we differentiate, where do we have commonalities, can we split the work, how do we organize ourselves? Because as I mentioned in my talk today, it's an industry challenge, not one consortium will solve it. Each consortium has its benefits and its drawbacks, so we really need to talk to each other and identify where are our boundaries and how can we collaborate with each other. Yeah, so I would really vote for a summit in the second half of the year, and I would also make my voice strong in the Autosar community to make that happen between the big ones. And luckily I also have colleagues in my team which are in Eclipse and in Selfie, so we might be able to pull this off. But this is what the industry needs right now. Such a summit. Yeah.
We will bring as well to highlight the idea as well, common goal, the time-bound goal.
Yeah.
Because I'm afraid it's nice to see each other after 2 years off, Exactly, and we can move to Madrid, or we can move to Oslo, we can move to London, and so on, in 5 years' time from now. And so this is defining very easy for me because I am a vendor, so it's very high level what I'm doing for me. But defining a goal, what is a project definition with boundaries around, and this is what we want to do, and then to embrace all the decision-making people as a vision to make it happen.
But then this summit might really make sense because it's not just enough that we in COVESA decide, okay, that's a good thing, because we need also the commitment from other parts.
I mean,
but one doesn't go. I totally.
Yeah,
one doesn't prevent the other one.
Yeah.
Maybe such a summit could be entered with a draft of such a goal, and the summit could be used to draft to finalize it, go together. So it's like, okay, we agree to that goal, and now let's see how we set up ourselves to reach it. Yeah.
And we would need working sessions like this one, the open session. Or
I'm willing to
interactive
bring in
discussion.
at least
But
my
maybe a
colleagues.
bit structured with, okay, we want to define the scope, we want to define the timeline.
Even more energy to fighting discussing.
Sorry.
We'll bring Graham. I feel that I have to also bring in the academic aspect of this. So I think everything that I've seen here, all the stuff that you guys are doing, the software efforts that are going on and so forth, I think they could
software-defined vehicle, it needs standardized or commonized API identification should be necessary. But in the perspective, I think all the OEMs need to have the same page because the JV also even IDI perspective development, most of the scenarios and the APIs were identified together, but not well commercialized because only at the time BMW is participates very aggressively, or other OEMs not well participated. So it was not well commercialized at the time. So for COVESA community, I think for to make the standard based some APIs, OEM needed to collaborate.
So I am not an automotive expert by any stretch, but it seems to me that if there was a killer app for educational purposes, not for real life saving money at Renault or whatever, but just we all know any new initiative has to be evangelized, there has to be proof points, there has to be something tangible to say, oh, you can do that? Yeah, let's do more of that, right? Matt was casting this vision in the keynote about automakers and tier ones have legacy stuff, services, whatever, set the seat to this thing. But they want to be able to add service levels to that legacy. And that little 6-inch arrow from legacy to new service seems like the killer app for SDV. Am I right? If we could develop a few proof of concepts of how we added services that extended legacy services, that's what we're looking for here, right?
I agree that these simple use cases help to convince or we found that there isn't even not one use case to show off exactly what SDV opens. You have something like quality issues you can get out of, so we only use cases. You have, okay, you want to do some control of some safety. So we came up to four kind of common use cases, which helps us to somehow spread the solution room, and then since then we can discuss more clearly. So that's why I like your approach, that let's somehow define that, which are the use cases for us, that we are not all the time talking, okay, I'm talking about quality, the next is talking about some service in the cloud and so on. And this helps a lot in the communication. So yes, at least it's true.
I would argue that today there is not necessarily identified what a good computer are, but the thing of the SDV is it's opening up a whole new potential to build them which doesn't exist today.
Right.
And there is one of the areas to build all these new services and killer apps and making the software evolutive to get there. And the other is that you can do product improvement without changing hardware with the software-defined vehicle to a great extent by making things configurable in life cycle to get information out of the car that is just used to improve the product.
I missed the introduction myself at the beginning from JC. When you talk about the killer use case, I had a thought different the killer use case in terms of the SDV in our industry. are some ways of idea, inspired by the cloud. So if you look at the history of the cloud involvement, revolution, they killed first the platform. Yeah, so they introduced PaaS, the platform as service, something like that. Then it's a very common sense nowadays, and it has been moved to the SaaS as services, as software as service. And they don't need to care about where your software running on. So since it is provided as service from the cloud, so let's say you previously run your application with the MySQL on the Linux. MySQL has some capabilities with Linux, right? For example, then no longer consider to where to run the MySQL by the SaaS. And then there's some thought about the FaaS, the function as service, something like that. Then even the software is no longer required, considered in your platform design, right? The software design, product design. So the platform has already removed the scalability has been also removed by introducing the SaaS. And the function PaaS is also introducing a new paradigm in the software development, in the product service.
But can we do this, the final step without the tree?
I'm saying, just I'm looking at how they evolve.
Evolve, yeah.
Totally. And we are talking about the software defined, and we are also getting some idea from the cloud. In the software especially. Right? So in the software, the idea is we have some environment running on the cloud, and also bring it to the test facility and bring it to the vehicle inside. So it is verified in the test facility, then it is guaranteed running in the vehicle side. This is the concept of software. And then, and one good idea in the software is putting the safety in the cloud native side. I'm not sure if it does make sense or not, realistic or not. But it's sort of difficult because as of now, in the vehicle side, we are looking at putting the safety certificate in the platform, like the tool set, something like that, right? But if it is sitting in the cloud native, the container runtime side and the REST API side, just to, let's say it is now in that area, no longer in the platform or the toolchain side. It is going to be killing the platform at the end. And why do we use Linux? If we use every OEM use SDB in the future, and why we use Linux? It can be running on the Windows as well. QNX.
Even out.
Yeah. So it's a different point of view regarding the killing use case. It's killing the platform use case going forward. When you make your application service for vehicle, let's say it is built as a cloud native, sort of cloud native for the vehicle. Yeah, you no longer require to consider to what programming language you use. Right. In the cloud side, the programming language in the cloud native side no longer important. Every language you can use, and in the web runtime, client side programming also is getting changed a lot by introducing the web assembly. So you don't have to only use JavaScript, which you can rebuild your source code. You can use C++ and compile it and run it in the web runtime. Similarly, the Rust, you can write the Rust code for the software-defined vehicle application running on the cloud, then compile it as a native and run it in the native platform vehicle. Then it is going to kill the needs of the programming language for auto-sum, so on, functional safety and so on. So
it's a nice twist of the
it's a little bit philosophical, but I have some different thought regarding the healing use case.
From kind of hearing today, the fact is, this is back to your point, that we need to bring more people from other industry. I mean, on the industrial segment, and since years now, I mean, the customers making the final product as equivalent to you, they have been spending more up to 80% of investment on software. Okay, and the subcontract they are most of the time. And define the hardware, and we see that, I saw that many times where visiting Siemens or people like this, the program manager used to be a hardware manager because there is no longer hardware to design anymore. Okay, and 80% is software. And the hearing use is going to be a trend as well. I mean, the automotive industry is getting that trend. Where, and it wouldn't have been the COVID, maybe in 10 years from now, Renault, Mercedes, BMW could have been a software company and subcontracting to a car and somewhere else in the world. COVID changed a lot of things for sure, but it could have been a way to take that direction.
Now I have one question. If I look at the history of the COVESA and GNB originally started to define a standard or a specification for IDI domain, right? At the time, there's no SDB, Linux, so TNX OS, this kind of OS was used in the digital cluster or the IDI. Now everybody uses the operating system in the other domain, like the HPC and so on, core computing system. That's why we are calling, I think the COVESA also restarted from the IDI domain to the more generally vehicle domain. And then now we are talking about SDB. And let's say in the future, as I just foreseen, if it became true, I mean the reality, the situation, then let's say there's no Linux required anymore. Everybody uses SDB, and every OEM uses some cloud native oriented approach for their SDB system. No longer the Linux QNX is no longer required. Then COVESA is going to keep have a deep bond of the Linux or to COVESA need to think a little bit differently going forward by introducing SDB more and more. So VSC is also part of the SDB, right? It's the part of the SDB, I would say. Then there will be new topic regarding SDB, which is going to kill the requirement of the OS.
Yep. Great point. And we are way over. But obviously we need to figure out a way to continue this discussion. And so that's on me. And I will make sure that I get notes out to everybody. And I didn't get everybody's name, but I have the address list or the list of attendees. So I think I got the names or some names and some of the company names. So I'll make sure I get this out to everybody. But we'll figure out a next step. I think another next step would be two steps. One is the summit idea. I think is a good one. But I think before that summit, there's some outreach to academia, there's some outreach, there's some more brainstorming and getting to some sort of a draft for discussion before we bring that summit together. So I can reach out to my Eclipse colleague and Michael Plague, and we have ARM represented in COVESA as well, so we have a Sophie contact there. And of course, Michael can represent AutoZar, so maybe I'll get an active thread going with all those organizations and tell them what we've talked about and go from there. Yeah? Okay. Thank you all. And there is there's drinks and snacks in the other room. So you've all earned one.
Schluss, Master Titel.